Welcome everyone. It is page 348. We are solving problems with congruence. We are going to reason abstractly and quantitatively. We're going to construct viable arguments, and we're going to critique the reasoning of others. We're going to solve some problems today, and we're going to use these note cards. So if you have CP, CTC, let's use it. You can find that one on page 177 and then again on page 337. We're also going to use reflexive property. This video, maybe the next one, but the reflexive property says that something is equivalent to itself. All right, page number, I don't have the page number on there, I need to get that done. We're also going to use the Isosceles Triangle base angles theorem. It says that if two sides of a triangle are congruent, then the base angles are congruent. And then we're going to use the side congruence theorem, and this one actually is fresh, but it's old. So use the resources that you have, flipping through the glossary and the postulates and theorems and the index in the back of the book to find the page numbers for the note cards that you don't have. I'll do the same, but off camera, and then I'll use those four as my justifications for the math we're going to do in this video. Page 348, let's go. Use any theorems you have proven, yeah, here we are, to solve each problem. That's how we'll explain it. Calculate AP. So AP, maybe bring in some highlight. This is what we're trying to find. If the perimeter of the triangle is 43 centimeters, since this triangle has two base angles that are congruent, I can use Isosceles Triangle base angles theorem, or the converse of it, to show that this side AP is exactly the same as the side AY. Little extra over there. So that means in our problem that I can write a formula something like this. I can say 43 is the total perimeter. It's the 13 along the bottom plus this unknown side plus this unknown side. And if I can solve for x in this problem, then I've figured out how long AP is, right? Perimeter is all of the space or the distance around the outside of the shape. So 43 equals 13 plus x. That's justified with the Isosceles Triangle base angles theorem. It says that in an isosceles triangle, if the angles are the same, the sides across from those angles are the same. So since both of these angles are 70, that means that both of these sides are the same length, and I don't know what they are, so I'm going to use x. Solve for x. Combine like terms first. So I'm going to combine x plus x to make 2x's. The 13 did nothing with that. The 43 did nothing with that, and the equal sign still has to be there. Solve for x. The next number we should focus on is 13. So I'm going to subtract 13 from this side. I'm going to make the 13 cancel. And I stack it like this for the way that I'm just conditioned to write it. You might see it written on the back end like over here, like it's making a full long like linear sentence. I'm not writing it this way, but Mathia does it that way. There's no difference. It's just structure. I wrote it like this. I can actually do this mental math. I can do this math without a calculator. What's 43 minus 13? The 3's cancel, become a 0, the format, so it's 30. Okay, simplify and now rewrite. So I've simplified by subtracting. Some things become 0, so they're gone. I'm not going to write anything anymore. The only thing left is 2x. In order to solve for x, there's still a 2 that's involved. We have to divide by 2. 15. That's how long AP is. We can say this is the measurement of, oh my goodness, of AP. Okay, let's go ahead and take a look at the second question. Question 2. Calculate MT. Let me say this better. Calculate the measure of angle T. And so in order to calculate the measure of angle T, I notice that it is spotted up right here on the bottom. Let's bring in some color to make it visible, right? Little Bob Ross, happy color. Here we go, happy angle. Now, I need to find the right note card, and I realize now that I didn't spot this one in the beginning. I have to justify how I know what my angle is. And I noticed that angle 117, being on the outside of the problem, is setting up a specific note card. It's this one. No, it's not this one. I saw the word exterior and thought I found it. It's an exterior angle, right? When you have an exterior angle of a triangle, that exterior angle says that the sum of the two insides will be the same. Ooh, okay, no, wait. I'm still thinking here. I'm going through my list, and I want to kind of show you that we've done a lot of these over the course of this topic. I'm looking for a specific one. I've gone through all of my cards. I haven't found the one that's needed because I skipped over it. Nope. All of these, yes, should be something that you have seen at least once before. I'm trying to answer question 2 and have a justification for question 2 that you should probably write down, right? I should probably write down as well. There we go. The linear pair postulate says that if two angles are the same, they are supplementary. So if we know that angle 117 on the exterior of the triangle has a matching partner on the inside of the triangle, then it's easy to calculate. You just do 180 minus 117. I should write it in a stack. Okay, so remember, you have to beg borrow. So we're going to borrow from the 8 to give to the 0 to make the 0 a 10. But then the 8 becomes a 7. Then we go 10 minus 7 is a 3. 7 minus 1, that's easy. That's a 6. The 1 minus 1 makes a 0, so I'm done. So therefore, I'm going to put a 63 degrees in that section. And if I needed to add them up, I would get 180, so I know they're right. Okay. Once again, that is linear pair. A linear pair is the reason for me that I can know this one. Now I'm going to bring back the other thing that we know. We know that in an isosceles triangle, base angles are going to be the same. So I know that I have an isosceles triangle because these two sides have double spikes on them. They must be the same length, which means that 63 degrees shows up at angle M and 63 degrees shows up at angle W. So I'm going to write a 63 in that corner. All of the angles in a triangle add up to 180 degrees. That is the triangle sum theorem. So since I know that all three angles should add up to 180 degrees, I can write an equation and solve it. I can say 180 equals 63 plus 63 plus x. Combine like terms. On this side of the equation, the 63s we will add together. So that will give us 3 plus 3 makes 6. 60 plus 60 makes 120. So 126. And then simplify. Now I'm showing the simplify step. You might just go to your calculator and just subtract and you're done. And that's totally fine. But I'm going to also show these for building algebra solving concepts. To get the x by itself, x is angle t, by the way. To get x by itself, I'm going to subtract 126. Subtract 126, subtract 126. Those become 0 because I canceled it. I've subtracted it from itself. What is 180 minus 126? Well, let's do this without a calculator. So, yeah, sure, 8 minus 2 is 6. However, 6 is bigger than 0. So we're going to borrow from the 8, make the 0 into a 10 by sending a 10 down. And so then it's going to be 10 minus 6. And it's no longer 8, it's now 7. 7 minus 2 makes 5. The 1 and the 1 cancel, so we're actually done. 54 equals x, which is also, of course, the measure of angle t. And we're done. There is one more question here. It's question 3. And it is, lighting booms on a Ferris wheel consist of 4 steel beams that have cables and the light bulb with the light bulbs attached. These beams, so there, and there, are along the these beams, along with 3 shorter beams, form the edges of 3 congruent isosceles triangles as shown. So isosceles triangle, isosceles triangle, isosceles triangle. Maintenance crews install new lighting along the 4 longer beams. Calculate the total length of the lighting needed. So one thing that I know is that if they're installing lighting along the 4, I'm just going to make sure it's visible. So they're going to put lighting here. They're going to put lighting here, and lighting here. And you know what? It's an isosceles triangle. That means that this leg is the same as this one. This one is the same as this one. This one is the same as this one. So by the isosceles triangle base angles theorem, which says that if the If you have an isosceles triangle, then the two sides of the triangle are congruent. And there are, in fact, 1, 2, 3, 4 of them. So 4 out of those triangles, 4 sides are the same because there's multiple triangles, right? And then they're all 25 feet in length. So when you do 4 times 25, you get the total length of lighting. This little apostrophe means feet. 25 feet. And 100. There it is. Go to page 349. More problems to follow.